Damn it! Wow, this is so sticky now. Only the front and the back paper came off, but all the sticky part is still on the... This is an old battery case I had lying around here in the garage. 12 volt, 100 ampere hours obviously. And I have recycled the cells for another project, because this was a prototype sent by a well-known battery company, which doesn't want to be named here. And the cells did not deliver the 100 ampere hours. Yo, that is much better. Clean up the case, because today is the day when we want to build this very special battery. And I've got this in mind for quite a while, and I just haven't got time for it. But now is the time, and I need it urgently because I want to test some more equipment, and exactly for that purpose I need this special battery. That is all perfectly clean now. It stinks in here. And look at this, these were the other ingredients of the battery case. It's a 100 amp JBD BMS. It did not come with a Bluetooth module. And look at this shitty job they did here. They used this silicone glue to isolate all the terminals and also glued in the display. It had like a battery capacity and voltage display there on top, which was never accurate. It's a 2-wire connector, so it only measures the voltage and then calculates the capacity, which is never ever accurate. And then there were these epoxy sheets inside, and everything was full of this white glue. They used some of these EVA foam here as blocks to clamp in the cells in this case. It was really not a nice build. Oh geez, this will take forever, guys. Let me remove this glue from these terminals and then I take off all the cables, because I just want to get the lid for this case with the main terminals, and all the other stuff can go into the recycling bin, really. I'm not using this BMS anymore. It's a 100 amp BMS without Bluetooth. So it's a dumb BMS. You cannot change any settings, nothing. Anyway, on the positive side, we got some rain last night. Very nice. Beautiful. The grass is coming back. So welcome back to the off-grid garage in rainy, cold Australia. We've got 6 amps outside. Well, we are at 80% state of charge, so... Alright my friends, in today's video we want to finally build this special battery here, and I've cleaned everything from the outside as good as it gets. At least it's not sticky anymore. And I'm not sure if I use this voltage meter. I need to look it up and see if we can use it for 48 volt, because this is exactly what we are going to build today. A 48 volt battery in a 12 volt battery case. What? Okay guys, let me remove all this glue shit here from these terminals, and then we finally build this battery. So I think that's it. This is all the rubber silicone glue. Yeah, that's how companies used to build batteries. I hope they are not doing this anymore. So this is now probably as clean as it gets. The lid still looks messy inside. I cleaned up the terminals as good as possible. There's still some silicone, and I have to find out if this display actually works with 48 volt. Well, let's give it a try. Positive, negative, shows us the voltage, and if I press the button, it turns off. Okay, 100%, 14.5 volts. Okay, let's go a bit higher and see. 24, 30, 40, 50, 55 volts. And that is the maximum we can set with the adjustable power supply. 58.59 volts, 60 volts. It still works. Perfect. I'll take it. That is weird, huh? At 14 point something volts, it always showed 100% state of charge of the battery. How does it now? We are charging now to 58 volt, and this is our new 100%. I don't think the actual capacity measurement or calculation in this device is actually accurate, but as long as it shows the overall pack voltage, That's good enough. Okay, in this battery case, we will put a 48-volt battery inside. 24 48-volt plus a 16S capacitive active balancer from knee, a mechanical switch to toggle this balancer, and I have to apologize, I'm actually not well prepared for this video. The Frankenstein battery. Hang on. We need parts of the Frankenstein battery, which is in this case. Yes, here it is. The good old Frankenstein battery. Yeah, if you haven't seen the videos here, this is a battery I put together from very old cells, from very new cells. B crate, A crate, certified, not certified, double pole terminals, older terminals. Some of the terminals have actually stripped, so I had to replace them. 5 different manufacturers of batteries, 280, 304 ampere hours, all in series connected in one battery here. Totally flat cells with already swollen cells, everything compressed in this Seplos do-it-yourself case. That's why it's called the Frankenstein battery. And it works amazingly well. We will get back to the Frankenstein battery at some stage, but at the moment I need this terminal block down here. So I've just taken off all these balance cables here connected to these terminals, and I think I found 2 more stripped terminals here for the EVE LF304. These are from September 21, so they are exactly 3 years old here in the off-grid garage, but I think these were already almost 1 year old when I got them. And I think this terminal and this terminal here is not good anymore. When I tighten it, it's really soft. And these were the old terminals with the M6 thread inside. So you had to put a set screw in it and then tighten it only with a very low torque. Otherwise you strip the whole thread out of this aluminium terminal. But thankfully there is a very quick fix for that. I'll show you in a future video when we do more work with the Frankenstein battery. Yes, we will do more work with the Frankenstein battery. Yes. Okay, I should be able to take this off without any problems. Nice. Yes. So this one goes into our new battery build as well. Well, not quite inside, but it will sit on the outside of the box. And that's pretty much it. That's our whole battery we are building. Huh? What? A BMS? No. The battery doesn't need a BMS. From now on, we are only doing bottom balancing and we don't need a BMS anymore. That's what people told me. I've just received a severe weather warning on the mobile phone and there's actually some nasty stuff on the way. Not as bad as in Florida, but we could still see some hail here. So if it gets a bit loud while we are building this battery, you know why. So before we put these battery blocks inside this case here, I want to introduce these batteries actually. So these are Liitokala 32700. A while back someone left a comment under one of my videos when we tested the Palo cells, which are very similar to these ones here, and said Liitokala is Finnish and means cold fish. Is that true or was he just joking? Funny that. Okay, these are 32700 cells with apparently 7 ampere hours. So yes, we are building a 48 volt 7 ampere hour battery. Andy, why would you build a 48 volt 7 ampere hour battery? This block goes in here, this block goes in here. Oh, there's still plenty of space. Look at this. You could actually build a fairly large battery here. I'm sure you can somehow optimize that and get another. There are a lot of possibilities to arrange these packs here. And I bought these batteries here from AliExpress. I have not tested them at all. So I'm not sure if they have really 7 ampere hours or maybe only 5 ampere hours like the Palo cells we have tested before here. Because they were supposed to have 7 point something ampere hours as well. And we could barely measure 5 ampere hours. So So I don't know, it will be an interesting test to see how much capacity we actually get out of these blocks here. As I said, I bought them from AliExpress and they sell them in 2S, 4S, 8S configurations already. They're already glued together, welded with these bus bar strips here. And they were like $40, $45 or something a block. So pretty cheap. And I said, well, for 80 bucks, I can build a 48 volt battery. We put an active balancer inside, have this terminal block outside of the battery, and can use this for testing BMSs and active balancers and all kind of other equipment which needs 12 volt, 24 or 48 volt. Because honestly, using this Frankenstein battery was a lot of fun, you know, but it always takes forever to recharge it. And then you want to do a low voltage discharge test with a BMS and you have to discharge 280, 304 ampere hours into something. You don't want to waste it, you know. And I thought the smaller battery makes perfectly sense. And the specifications of these batteries actually say we can discharge them with 5C. So that would be 1 hour and they are flat. Well, we don't want to do this, but a smaller capacity is far more convenient. We can use the adjustable power supplies and do whatever we need to do. So anyway, these two battery blocks go inside the battery case, 48 volt. Then we put the active balancer on top of it. Have a little switch somewhere on the outside to turn on this balancer just in case we need it. And now if I test a 12 volt battery or a 24 volt battery, I only use parts of this whole pack and then afterwards everything is unbalanced again. So I thought I'm putting in this active balancer here and we can quickly rebalance the whole battery without putting a BMS onto this pack then. And then we put this terminal block somehow, probably somewhere here on the outside or so. Yeah, that's why I said this is a battery we have not built before. Yeah, it's only 7 ampere hours large, but 48 volt. So in theory, we can actually parallel this battery with our battery shelf. Yeah, it's the same chemistry, lithium iron phosphate, and we just put this battery in parallel with our battery bank and charge it from 14.4 kilowatt of solar. That'll be interesting. Well, if you remember, we have done this before, yeah? We have paralleled 12 volt battery, 300 ampere hours with a 12 volt battery, 5 ampere hours, each with their own BMS, and it has worked perfectly fine. I'll link this video down below. Oh, I can hear the thunder. Oh, here it comes. Yep, there's the rain. Okay, I think we postponed this project here for a moment. I probably go inside the house because otherwise if this rain comes here I'm not able to get back to the house. No, you know what? We stay in the garage and see what's happening. Oh, that looks nasty. And I'm probably adding another terminal here on this side, number 17, or our main positive of the battery. I know it is the same as our terminal number 16 here, but I would like to have this separate. And by the way, these terminal blocks, they have a you can open them up and they have got a built-in 5 amp fuse. How good is that? As always, I'll link these ones and these battery blocks here and the active balancer down under the video. Guys, I need to repeat this all the time in every video because people sending me emails and saying, where can I buy these terminal blocks? Hey, where can I buy these battery blocks? Where can I buy these active balancers? Yeah, I'm getting a lot of emails. Guys, please don't send me emails. Leave all your questions under the video. Thank you very much. And I have to use the number 17 for this last terminal. I don't have a plus symbol or something then, so it'll be number 17. Ooh, the wind is picking up. All right, solar production is on 0, everything has turned off, and here's the rain. Okay, I close the garage door now. All right, that'll be nasty. And close the window. There's the hail. We're still making 5.3 watts. Just have a brief look. It's only raining. It was so loud. Winter Wonderland. Oh wow. Holy shit. Wow, what a storm. Look at all this hail here. Look at the plant. There's nothing left. Oh wow. There's washed away my driveway again up there. There's ice piling up at the gutter on the roof. That was a lot of water. Not only outside, but also inside. This is the only dry spot here, where the batteries are actually. Everything else is going through the garage and out of the door. Crazy! Guys, welcome back to the video. Welcome back after this storm. Oh wow, that was one of the biggest storms we have ever experienced here in this location for the last 16 years, pretty much since we moved here. Insane. So there was no way to continue this video that day, that night actually. Well, we had all this flash flooding around the house and all the mud were everywhere on the pavers, on the veranda, everywhere. And the river coming down here washed away all my driveway. So luckily we have only a bit of damage in the garden, in the yard, but nothing in the garage itself, nothing on the house. But I was trapped here in the garage for almost an hour. Yeah, I couldn't get out. I had to wear my earmuffs all the time and had to cover the dog's ears for about 20 minutes. Yeah, and because the gutters around the garage, they filled up with ice, all the water came down and caused this flooding here inside the garage. The water level is then rising because the drain pipe cannot take it anymore. And then at some stage, the water comes into the garage. But I've never seen that much water inside the garage ever before here. I had a tiny bit of water here in the garage after a big storm before, but this time it was just so much water. So I cleaned out all the shelves underneath, get this all dried out with a fan. We had no issues here because all the batteries are sitting on wheels, probably 100 millimeters off the ground. There was a bit water around the battery shelf, but this is all siliconed in, as you remember. And this is all dried out again now. And we lost another big tree in the backyard as well. I tell you, chaos everywhere. So the next day, because it was my wife's birthday, we just went away for the whole day, you know? We just left all the chaos here, all the mud, all the water. And interestingly, after 20 hours, there was still some hail present in some locations of the garden. And we had like 23 degrees. You know, it was just too much. There was dirt and mud and leaves and twigs and branches everywhere in the garden. And we just didn't know where to start. So we just left for the whole day. Yeah, and then Friday we started cleaning up around the house, which took us the whole day basically. And Saturday we met with the family to celebrate her birthday. We went away again. And this morning we continued cleaning up the yard and the garden and everything. But it's still not done. There's so much material which needs to go. So I need to free up the trailer with all my plasterboard for my battery room now, to fill this up with all the debris and dirt and mud, and then bring this all to green waste recycling. But this is a task for another day. Today is Sunday. Today is Sunday, 4 days later after this weather event. So we want to finally continue with building our 48 volt and 7 amp hour battery, right? I have already mounted the active balancer on one of these 3D printed boards. Don't need to mount it or something, it just sits inside here. I used some of the foam blocks I had here to squeeze in these battery blocks so they're not rattling around. But apart from that, I won't do anything else here. So next step would be to mount this terminal block here on the outside of this battery case and also the switch. Okay, let's take some of these terminal blocks out because I need to drill another hole in the DIN rail. So, and I think we just put it somewhere here. Okay, bombenfest. 17. I'm using these two stoppers here to hold them in place. Ah, come on! There we go. Okay, I'm just trying to find the on position. That's on, off, off. Is off down or off up? On, off, or off, on? Leave your comments down below. So I have drilled 18 holes just underneath this terminal block here, and unfortunately we have to cut off these ring lugs now, so I probably cut them off somewhere over here and then pull them all in, and then we have to cut them again once we know which terminal they connect to. Man, it's like going to the hairdresser and getting your long hair cut off. Alright, so cable number 1 goes in here. I need both hands. It is beautiful, beautiful. Not so much in here. So now we have to wire all these cables here to these battery cells here. Starting with the first cable, which is our terminal 0, which is the main negative of the whole battery. This is this contact over here. But then cell number 1 is not on this side, it's on the other side. Needs to go through here because this is our cell number 1, but the positive is on the other side. The positive pole of the odd batteries is always on the underside. So 1, 3, 5, 7. So we can pull the cable back. Alright, so this is basically my longest cable I have to cell number 1. And then later on we use some Velcro to organize all these cables here. Okay, I think you get the point. Let me continue my work here and then I'll show you how it looks like. Alright my friends, after half an hour, 45 minutes, we are almost done. So I have now wired all the battery cells to these terminals, and I've also included, of course, the balance cables for our active balancer. So the only thing I haven't done yet is to measure the voltage of the terminals. So the first terminal number 0 here is the main negative of the battery. First one is of course battery number 1, so we should see around 3.1, 3.2 volts. There we go, 3.1 volts. Next one should be 6.5 or so, 6.2. Then 9.3, 12, 15, and 50 volts. And our terminal number 17 is the same as number 16. That should show us 49.9 volts as well. So I just made sure that all these terminals are in the right order and connected to the right cells. And we want to do the same with the balance cables as well. So number 1, cell 1, cell 2, 9 volts, 12, 15, 18, 21, 24. And then we continue with the next set of balance cables. 28, 31, 34, 37, 40, 43, 46, 50. Okay, exactly the same. Perfect. So everything is in the right order. You should always measure this before you connect a BMS or an active balancer, that all your cables and all your terminals are in the right order. Otherwise there may be tears, you know, destroying your BMS or your active balancer. So I have tried to organize these cables as good as possible. We've got 2 strings here, number 1 to 8 and 9 to 16. And of course I used some Velcro. Some people call me Mr. Velcro. This is the Velcro I use. I'll link this down below. And it organizes the cables always perfectly. I'm really a big fan of Velcro. You can always undo it, add more cables or take some away, put the Velcro back on, and everything looks always nice and tidy. So, and in the last step, we want to connect the switch here to the active balancer so we can manually turn it on and off. Yeah. And here on this knee active balancer, you can see the little run solder plop down here. So we have to take this one off Underneath are two contacts, and they are obviously now soldered together. So as soon as you plug in all your cables, the balancer will start running. And this is exactly what we don't want. Yeah, with lithium iron phosphate cells, we don't want to balance all the time, because the balancer will do the exact opposite what it's supposed to do. It unbalances your pack if it runs all the time. Yeah, we have done here many tests on the channel, and I've just got an example for you here. This is the 12 volt 200 ampere hour Müller battery, which I use to connect to the Peter inverter, yeah, to run my electric chainsaw and the garden shredder wherever I am on the property here. So this is a very robust battery, but it also has a 4S active balancer inside, which runs all the time. And I haven't used this battery here for the last 5-6 months or so. So it was sitting here with around 30 to 40%. And I've recharged it now after this hibernation period. And guess what? The top balancing was completely destroyed, yeah? So while charging, one cell hit already 3.6 volts, while the other cell with the lowest voltage was still at 3.28 volts. And I did a full top balancing before with this battery, before I left it here in the garage, because I didn't use it. Yeah, it was 100% top balanced. And because at 30-40% state of charge of this battery, the voltages of all 4 cells are pretty much identical, yeah? There's still a couple of millivolt difference, of course. And this is exactly what this active balancer picks up and starts balancing. So it tries to bring all these 4 cells in this battery to the same voltage. Because we are in the flat area of the voltage curve, it takes forever to do this. But the balancer had time for months, and it obviously was able to move quite a lot of ampere hours between the battery cells. And when we recharged it, there was a total mess, a chaos. The top balancing previous done was completely destroyed, and it took 3 or 4 days until this little balancer was able to restore the full top balance again. So never let the balancer run all the time with lithium iron phosphate. If you have lithium ion batteries, that's totally fine, different thing. But with lithium iron phosphate here, it needs some control, either manual or automatic, to control the active balancer. So here in this case, we use a mechanical switch to toggle the active balancer. We only turn it on if we need it, and most of the time it will just be off anyway. Okay, we just take off this solder plop here on this PCB. And there we can see the 2 contacts underneath, which were connected with a solder. And this is exactly where we connect these 2 cables going to our switch, so we can manually turn it off and on. This connector over here. This connector on this side. Always getting scared. There's always a little bit of a spark when you connect these cables, because all these capacitors are charging up. Jeez, and it always scares the shit out of me, of course. And we should see a LED. I think it's somewhere in this area there when I turn on the balancer. Yeah, you can see it. There you can see the reflection on the plastic. The yellow light. Yeah, active balancer on, off, on, off. Cool. So I've now just integrated the small cables here into my existing Velcro. That's why Velcro is so good. Alright, and this concludes the build of our test battery. 48 volts, 7 ampere hours. Wow. What I have forgotten is to integrate these 2 cables here for the display. It shows us the overall battery voltage. I'm not even sure if I bother connecting them anymore, because the overall voltage is clearly not as important as all the single cell voltages we have in here. But for now, everything is finished. So at this stage, I'm not going to connect these main terminals here to the battery. So in the next step, we probably connect a BMS here and fully charge these battery cells here, and do a bit of a capacity test as well to see how much do these cold fish cells, Liitokala, actually have. Yeah, can they deliver 7 ampere hours, or are we ending up again with 5 ampere hours, like with the Palo cells as well? But before we do that, there's another video coming up. Victron got in contact with me in regards to the electric vehicle charging station and the video I made about. So there will be some very interesting stuff coming up. Alright, my friends, I'm very sorry we have to skip the subscriber count today because, as you can see, it's a total mess here. All the numbers came down in the big storm. So I'm completely unaware what numbers we have now, and it is already a late night show again. After 4 days, I want to really finalize this video now. So thank you very much for all your support here. Welcome to all the new subscribers. A special thanks always goes to the people who are donating to the channel. Buy me a beer, a coffee, or clicking the thanks button under the video. So thank you very, very much for everything you are doing here, because this makes these videos possible here. And until the next video, guys, when we do something completely different again, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. 48 volt, 7 amp hours, or maybe only 5, we don't know yet.